Hi everybody, my name is Brian Anderson and I'm here to tell you about the theories of color vision, which are, shockingly enough, covered in the chapter and lecture. So I'm going to pretend like I know things. So to start, we have the Young-Helmholtz theory. In about 1672, Newton showed that light passes through a prism. Splits into its component colors, which is the rainbow, which then caused speculation that each color corresponds to a different wavelength. We know this is true, but the perception of color actually exists within the observer, not within the light itself, as it's us just perceiving a wavelength type. In our eyes, we have two different major types of receptors, rods and cones. Rods are used to detect small changes in light level and movement, and are focused somewhat away, like in the periphery of the fovea, which you can think of as the center of your eye. Cones, which detect color, are actually pretty heavily concentrated in the fovea. And then we have three kinds of cones, which are red, blue, and green. And they are named this way because each kind is maximally sensitive, if I could talk, to that kind of light. So when a wavelength of light comes in that hits those colors, that cone is peaking activity. And then if it's like middling between two of the colors, then they go up in proportion to that wavelength, which gives us our various perceptions of color. And in some cases, an individual will not have one of these cones, or will have a faulty one, which means they can't experience that color, which is red-green blindness, for the sake of color blindness. As an extreme example, sharks can only see in black and white because they only have one cone type. And on the other extreme, mantis shrimp have 16 cone types, so that's just a ridiculous amount, and so many. Another theory of color vision is from Ewald Hering, and I really hope I'm pronouncing his name right, because I would feel ashamed if I was pronouncing some psychologically important figure wrong, like fruit or something. I'm sorry, I think I'm funny. He had some problems with the previous theory. He noticed that mixings of some colors gave the sensation of gray, and noticed that some colors would leave after images if stared at for a period of time, but that after image color would not be the same color as the original one. And so he came up with and proposed a theory that each kind of cone, red, green, and blue again, can have a buildup and tire the eye. The color red was paired with green, blue with yellow, and black with white. And when one color from the pair was observed for a period of time, the eye would get tired or fatigued, and when that color then changed to like a background of white, the after image would revert to the other color in the pair. Another example or explanation is your eye automatically subtracts the color that it was already looking at, and then you're left with the opposing color. The next theory is Christine Ladd Franklin's. She proposed her own theory that was based on evolutionary trends. She believed the fovea to be the most evolutionarily advanced part of the eye, and that the eye, the further away you got from the fovea, so closer to the periphery, it became more primitive. Her reasoning for this was that the closer to the fovea one was, the more one could experience color, as that's where most of the cones are concentrated, and that the further one was, the less color one could perceive, which is not entire. It's weird, but away from the fovea are more rods, which means we're better able to detect movement and changes in light level. Ladd Franklin believed that achromatic vision came first, so just like the movement, black-white, and then blue-yellow sensitivity, and then green-red sensitivity, and they evolved in that order, and that's why that kind of vision is rarer, I guess, or red-green color blindness is a thing. That's all that's talked about in the book, but I'm going to very briefly talk about something that I went over in my behavioral neuroscience class last year, which is the Retnex theory, and I think it's important, so I'm going to talk about it and waste your time. It was proposed by a dude named Edward Land, and is a theory of color constancy, which means we can still identify an object as being a color even when it's in different levels of light. So an example of this is like if you look at a Rubik's Cube and you see there's orange, green, and white squares, even if you put it in the shade, you can still tell that that's orange, green, and white, even though it's technically changed to your perception. Anyway, that's a super simplified version, but that's what I got for you, and I will see you all in 2 weeks. Bye-bye, be safe, don't do drugs. Okay, see you in a bit.